All right, let's go ahead and get started. Our next research presentation comes from Professor Darcy Bullock. Dr. Bullock earned his Ph.D. in civil engineering from Carnegie Mellon University in 1992. Bullock is the Lyles Family Professor of Civil Engineering at Purdue University and serves as the director of the Joint Transportation Research Program. Bullock is a registered professional engineer in Indiana and has 30 years of experience in the industry, working closely with airports, transportation agencies, the automotive industry, and private sector partners. Bullock is currently leading several projects related to connected and autonomous vehicles and pro-vehicle analytics. Without any further ado, let's welcome Dr. Darcy Bullock.
Okay, guys, some of you have been to my presentations before. I like these to be interactive, so I hope we get questions as we go along, and if not, I might start calling on people. So what I wanted to talk about today is integrating connected vehicle data into winter operations. I think the part that kind of ties this, Calvin's been working with us on a project on automated brine application. And when we start thinking about winter operations, that's the process of going out there and either the anti-icing or de-icing of roads and plowing. And I don't know what the numbers here are in Michigan, but certainly in Indiana, a full call-out is well over 1,000 trucks just on state roads. That's looking at excluding local agencies. And a important complement on that data set is deploying connected vehicle data. So we don't know just how hard we're working, but we measure how well we're doing. And when we talk about connected vehicle data, we worry about two parts of that. We certainly can control the connected vehicle data coming in from our trucks, knowing where they are. But more importantly, we want to see how we're doing on those roads. So what I'm going to do is talk to you a little bit about that. And so kind of the way I've kind of got this talk structured, just the salt budget in Indiana varies between $30 and $60 million. That's just the salt. So this is an important problem that's got some big dollar values on knowing how we're doing, as well as safety benefits. Where we have come in the last, probably 10 years ago, we were using crowdsourced data as an experimental data source. In the last three years, it is just a mainstream data set. In Indiana, we ingest about 13 billion records a month of connected vehicle data, and we ingest an even larger number of kind of some of the U.S. National Weather Service rapid refresh data. Before I do that, I just want to give a little bit of a shameless plug for the demonstration that we're going to have out there in the lot. Henry Center, the CCAT Center, has funded what we call this automated brine vehicle. INDOT is en route with a deployment. We built this automated brine application vehicle on a small electric vehicle. We'll have this up here this afternoon. But based on the results from that CCAT project, INDOT has now scaled this to 8 or 10 trucks. I can't remember the exact number. They're still building. It will be at 10. So we have 10 of these trucks that have been outfitted with this automated brine application. Quite honestly, it's adapting some of the precision ag concepts to roadway brine. And when we talk about de-icing, everybody's seen the vehicles out there that are putting down the de-icing chemicals. When we drive the 465 route, a driver takes his hands off the wheel 600 times to move a switch to turn the brine on and off for each of the bridges. So if we can keep the wheels on, not only are we going to be improving the consistency, but we're absolutely going to be reducing the distracted driving. So please go out to the parking lot. Students will be out there this afternoon. Calvin's done some remarkable design build on the schedule to accommodate with the weather. So I just want to make sure you guys go out and see that and see the students. INDOT will have a driver up here and you'll get a chance to see that vehicle. So now back to my regular scheduled program. I wanted to do a little shameless plug for the demo because it does tie in, right? I mean, when you look at that truck out there, 4,500 gallon truck, you don't there's a real cost on deploying assets like that. So you really want to have good quantitative data as you're managing that statewide system. So Henry and I testified in Congress. Gosh, it was 2019, Henry, right? I mean, the general message is our vehicles know more about our roads than we do as agencies. And I say that a little bit tongue-in-cheek, but when you think about, and the number here in Michigan's even better, but in Indiana, 5 to 6% of our vehicles are connected vehicles. Is probably a little bit north of 7% here in Michigan. And so what I want to talk about today is how we can use some of that data. And the preview of this is I've got some graphics in here. We looked at all 50 states for that big storm in December, so kind of preview ahead. When we get to the interactive part of this, I'll show you a neat little one came up I-65 through Kentucky and so on. But then I've got some slides in there that we can look at Michigan. I think I saw a lady from Colorado. Maybe we'll pull up the Colorado slides and look at that data. So when we start talking about connected vehicle data, this has evolved a lot over the last several years. We've had our challenges with folks having their eyes on the DSRC spectrum. That's still a little bit evolving, but when you bring in connected vehicle in terms of this talk, I'm talking about bringing in connected vehicle over some type of cellular type connection, typically on the order 3 to 5 second reporting frequency, latitude, longitude, speed, heading. There's further sets of connected vehicle data that we kind of broadly call enhanced probe data, things like traction control, ABS, hard braking. Those are things that are absolutely on the horizon that are just kind of in that exploratory stage. But instead of just kind of sitting on the sidelines saying, okay, this is what we really want to get there, I think we had a great talk earlier. The former Ford colleague talked about, okay, engineers, let's start building right now something we can do with this basic data set. And just to give you a magnitude of what that data set is, we analyzed the entire country in December. It was 503 billion records, and we did every interstate in every state minute by minute. And I'll show you a couple of those graphics towards the end. And you can see up here, it's no surprise, Michigan right here. You guys are, I'm pleased that we're getting 11 to 13 billion records a month in Indiana, and you guys are twice that, 26 billion records a month. So that data is here, available in real time. So every state out there, this data is available. You can use it. Little, of course, Texas and California, even bigger. And then the other data set that I'm going to talk about fusing this with is the National Weather Service produces what they call this rapid refresh data. It's nominally 3-kilometer grids, and you saw some of those graphics coming in. I had a little looping video, and I'll pull one of those up. Typically, the two data sets that we look at, there's a lot in there, but we typically look at the precipitation type, and the temperature. And if you recall that December storm, the front came in, and then the temperatures just plummeted. So it was a particularly challenging storm from kind of icing. So this is the graphic that I want you to look. Oh, sir.
Sorry, contextual question. The vehicle data that you gathered, what is the data like generally, or that's it right there? Okay, sorry, I missed it.
Yep.
Thank you.
Not nominally breadcrumbs that give you velocity and heading, and we also bring in hard braking that we use in work zone, but that's hard braking, hard acceleration. Good questions. Please interrupt as we go. I hate PowerPoint-induced coma, so I really would. You've set the bar now. If I start getting bored up here, I'll call on you for. Good. We got another question.
Question on the data. So is that basically the same? Is that coming from cell phone, like individual cell phone data, like aggregated to something, or is that when you say connected car? I mean, when I'm driving down the road, I can see the traffic. It's based on the cell phone Google Maps. Is that basically what this is coming from?
This is not cell phone data. This is coming from onboard telematics on the vehicle. It's consented, it's de-identified, and it's consistent with kind of the US and the EU privacy restrictions. Sir?
So, two questions. First of all, you mentioned that this is open source data.
I did not say open source data. It's available for purchase. And we're not selling. We buy our data from Wejo, but there are a number of different vendors out there that are starting to pop into this market. But when we compare, when we put 1 point out on the interstate, I put 1 point, power, communication, detection, that's $100,000, and that gives me one sample on the interstate. And if I can buy connected vehicle data and have statewide coverage or national coverage, that is an absolute game changer in terms of scalability and maintenance. We can't even keep pedestrian buttons working at traffic signals. So when I can outsource all that data collection, it is just wonderful. Excellent, excellent, excellent questions. Okay, yeah.
So you had 3 to 5 second interval
Yep.
between this data. Is that sufficient for a piece of?
So is 3 to 5 seconds sufficient? Absolutely. 3 to 5 seconds at 60 miles an hour, you're traveling a couple hundred feet. That's more than adequate. And I'll show you, and if we have a little bit of time during the Q&A, I'll show you some real-time dashboards we have in Indiana with the tornado that went through on Friday.
What is the purpose of like collecting this data from different vehicles, and for what application is it being used? And why do we have like a good advancements in some states, but like they are not really as much like used in the other states?
Okay, so there's two questions. One, why do your question is, don't just admire the data. What are we doing with it, right? So I'll tell you broadly, the 3 areas that we look at the data for is winter operations, how are we doing managing a storm? Work zone analytics during the summer, how are our construction zones operating? Where can we do things better? We're already, just this morning, had email traffic on some items that have popped up in the connected vehicle data. And then the third is traffic signal analytics. Where are there opportunities to do some green time reallocation? So those are the 3 use cases. What I'm going to talk about today is winter operations.
Mm-hmm. And the second question was like, what are the underlying factors contributed to some states are way further in this journey as compared to other states?
So it's vehicle penetration. It's what market share certain vehicles have, and if you follow up with me afterwards, I can send you a little map of what that relative penetration is. No state has less than penetration of 3%. The high end is maybe 7%. Wisconsin probably has the highest penetration. So let's look at this graphic right here. And I love to do these kind of mashups where we integrate different data sets. So what you see along the top is a map of the U.S. And I pointed out I-65 up there is the segment going north-south. And then down here towards the bottom, this is the hours the speed profiles are operating below 45. So I'll do this video here, and this one happens to be the temperature. Now watch the impact on I-65. And then we'll probably watch this a couple times, but if you look right up here, this is the time here, this is the date, December 22nd. Watch that. Do you see that whole front and temperature decrease come across, and you see the impact that it has on I-65? We'll watch this one more time. We're up to December 24th, 25th, so watch right here. When this date flips over, we'll be replaying the video. So December 21st. Now watch this. Now comes across an I-65 here. Watch I-65 go from green to red. So I hope what this shows you is you can see that, and it's no surprise, anybody who works in winter operations, weather impacts the roads, but we can see that correlation, and I like to just kind of show that example because I think it's a nice graphic interaction on. Now, if we look a little further, hang on. This is probably the most valuable graphic that we pull out of here, out of this data, and this is what we call our heat map. We actually draw these in real time, so it's not like the storm's over and then we see how we did. This is what we monitor in real time. This is a heat map during that storm from Alabama to Indiana. So audience participation right here. You can see the mile markers in Alabama, Tennessee, Kentucky, up into Indiana. December 19th, December 20th, 21. What date and time did the storm impact? What state and what mile marker? I gave you a lot of questions there. Who wants to be the first audience participation? Green is good. Reds and purples are slower speeds. Back row.
24th at 12, like just before 12.
So the 24th, this is the 24th.
Yeah.
So this is the 23rd. So maybe I would say on the 22nd, if we say this is noon, it probably started impacting here in Indiana. Do you see right there?
Yes.
But it
range.
didn't impact Tennessee here for maybe another 3 or 4 hours. Does that make sense? Does that make sense? So these heat maps are really valuable for kind of showing the data. The other thing that's kind of interesting on this is this also gives you a good idea of kind of that vehicle volume and penetration out there. Can you see these overnight hours? You have scarce data. You only see a few of those green lines. So those are overnight hours. This is where I'm just showing you connected cars right now. This is where we also bring in the connected truck data. Connected truck data, there's a lot more connected truck data at night, so that actually fills it in. I think I usually use this graphic because I think it's kind of nice to show that different volume. And then you can, yes?
Are each one of those, it looks like lines from here, are those the same vehicle traveling like north over time?
So what we do is we do one, it actually may be, it's at least one, sometimes it's 2 or 3 vehicles in the same segment. So what we do, again, to try to minimize bandwidth on the dashboard and not be tying to individual trajectories that you could match to a camera, we average them in 1 minute slices over quarter mile or so. But effectively what you see is during the middle of the day, you've definitely got multiple vehicles. At night, it's probably 1 vehicle in that 1 minute slice.
So is there a reason there's none going like, I'm assuming these are like northbound vehicles or clusters of vehicles, are there any southbound ones that would be slanting the other way?
Absolutely. So I can, when we get to kind of interactive, I've got some additional graphics on that. I usually show one direction at a time just to start that discussion. And I hope what comes across on this is this scales real well, right? We're sitting here in Indiana and we analyze the entire I-65 corridor. And then the other thing is when you start linearizing this, you can start now mapping additional attributes onto that probe data. So this particular shows the temperature, and you can see the temperature gradient moving from north to south here on I-65. And this, now it's not the trajectories, but I am, I'll come over here to, this is the one you want. This, I'm pulling in on I-65, so you can see in the northbound, see the N, that's the northbound direction. You can see that trajectory going that way. And then in the southbound, you can see these trajectories going here. And then you can also see there's a work zone downtown Indianapolis. You can see a little bit of queuing right there. And then this is up congestion, getting it up into Chicago, getting onto the roads going to Chicago or backing up right up there. So just to kind of give you try to tie in the data with the graphic image right here. When you look at this particular, this is mile marker 37. So mile marker 37 is right here. I hope what this graphic shows you is there's a pretty strong, you see the graphic, what the road conditions like. You're not surprised that we got slow speeds, the reds and purples for that. But I think you were the individual asked, why would you use this data, right? So when you've got 1,000 trucks out there controlled by 140 different units, all trying to work together as a team, all making individual decisions, trucks breaking down, we have periods of time when we have trucks that are maybe not deployed where they should be or over deployed. You can absolutely notice right here, do you see this boundary condition right here? We got great conditions right here, and then it gets real bad on the mile marker. Many times people are driving along the interstate, and it's sometimes the case. I'll probably say, oh, the weather got really bad. Generally, it's not the weather got really bad. You've now transitioned to a different jurisdiction where somebody has made a different decision on whether they're going to apply de-icing chemicals early, how aggressive they're going to be out there in front of the storm. And you can absolutely see there was a different decision made there that had an impact. So this is why we want those real-time dashboards, right? Does that make sense? So now let's kind of drill down a little bit on some of those performance measures. So I'm going to look at this, winter storm from February 16th to 18th. And we call this traffic ticker. And quite honestly, it's how many miles of interstate are operating below 45. It's just how can you at a glance see how are we doing out there? And you can see in February, we kind of have Monday, Tuesday, Wednesday, Thursday, Friday. Friday. If you had, there's a little winter event there on Saturday, Sunday, Monday, Tuesday, Wednesday. Do you see a pretty significant winter event right here? So these things kind of give you at a glance how bad are we doing at a statewide level. I don't need to bore the group with the details, but NDOT has 6 regions of the state. They name them Crawfordsville, Fort Wayne, Greenfield, LaPorte, Seymour, and Vincennes. The purple is the LaPorte district, which is up here in the near adjacent to Chicago. The Fort Wayne district, the black is the one that's probably a bit southwest here. This was the unfortunate outcome of less than perfect coordination on the storm. When you've got that tight, and once you, I know we've got a couple of people here that work in that winter operations space. Once you lose an interstate, and you have enough slide offs, you don't get it back for 24, 36 hours. Every state goes through one of these scenarios every couple of years. We all hold their breath when another state goes through it because we know our turn is next. And you can see all the trucks piled up there. So that's the why. Why do you want to use connected vehicle data? You want to see how your roads are doing so you can aggressively intervene and avoid those type of scenarios. So this shows what that particular storm, and the thing that you will see where that video was shown. Do you see right here from mile marker 200 to 220? This is where the closure was. We overlay here, these gray lines are our connected snowplows. So we overlay our connected snowplows on top of our probe data. What can you tell me about mile marker 200 to 220 about pre-treatment and getting connected trucks out ahead of that storm? Audience participation here. What do we not see here? Yeah, this is a hey, Hayden's in the back. Hayden and Justin are in the back. Two of the guys that actually created a couple of these slides. You can absolutely see that, right? The other thing you can see in the connected vehicle traces is you saw in that video the trucks are not moving, but do you see the cars moving up the side of the roads? So now let's go back and look at the heat map. Can you see the cars moving up the shoulders there? So you see very, very sparse data. And you see a little bit of traffic going through, and you see these long queues. So I hope what you're seeing in this connected vehicle data is you can see, you've seen these heat maps, you can see the storms rolling in, you can see where they're striking, you can see how traffic is behaving, and then we can drill into some of these anomalies of vehicles driving on the shoulder. Okay, now let's look at, we had a storm a couple weeks ago, so let's look at, I just grabbed the Fort Wayne district is in the northwest corner of Indiana, so I just grabbed this ticker, scrapes, actually Debbie grabbed these screen scrapes, I think, from, so November through December, so I'm going to go through step through month by month, November, December, January, February, March. And can you see the December storm? That was this is kind of summarizing. Remember I showed you that national storm going across the weather front just before Christmas. I can show you more details on the next slide now for that December storm. And again, if you look, I hope as you look through kind of that pulse on the network, you can see the month of December, we really didn't have any winter events up until about that time. And then you can see, okay, this had a big impact on the state. This is a really neat graphic that the team has put together, and you can see miles below 45. You can see the precipitation type starting out as rain and moving to snow. So right here, 11 a.m., life's pretty good, no precipitation, temperatures are above 30, and then by 11 o'clock at night, now we've moved into snow, and precipitations are plummeting 10 degrees, going down below 0, right? And then you can see the impact up there. And if we look at kind of that impact, we did a national ticker for as that storm that I showed you at the very beginning tracked across the country. This is for the interstates, and you can see the impact in Ohio and Kentucky and Indiana then. So now let's look at Indiana. I'm going to do one more deep dive. And so I was doing this talk, I said, okay, let's try to do a storm that's relatively recent and close to Michigan as we're coming up here. So I look at the March ticker, and I-69 is in the Fort Wayne district, and we see that the Fort Wayne district got hit on March 4th. And this is the part that's really, really cool now is we can start seeing across the border. So connected vehicle data, one of the things we do in the state of Indiana now is we purchase not just the state of Indiana, but we purchase a 10-mile border around it. And that's really important. So for both work zones and winter is now we've kind of got eyes across the border. So you think about our traditional way of deploying ITS assets. We've spent the last 20 years trying to figure out how to send data back and forth on detectors and cameras, and trying to get two different state IoTs or IT departments to work together. And it's state like Indiana, we border Ohio and Kentucky and Illinois and Michigan. The barriers to just trying to get that all worked out versus just buy from one data set. Let's just look across the border. Let's see how things are doing. This is pretty powerful. As you can see here, and by and large, there really wasn't much difference here between Indiana and Michigan. But I think the cool thing here is that you can see the impact of the storm up, and it does give you eyes across the border. So now coming back, this is that video again. December 21st, and then this is showing the front coming across the country, and then you see everything turn red up there. So I hope what you're seeing here when you look at this is everybody's used to looking at Google Maps as a snapshot. The power of connected vehicle data is it gives you, if you're looking at it in real time, maybe you're looking at what's the last 12 hours doing, or if you're looking at an after action, how we did, it gives you the ability to look at it. Nobody wants to like sit in front of their computer and like screen scrape Google Maps like every 5 minutes to put this thing together. But the connected vehicle data lets us look at any road, whether it be interstate or whether it be a surface street. So I think I've kind of gone through. This is the last part, and this is probably the new cool. Yes.
What type of infrastructures is required to collect all this data? So except from connected like data from the vehicles, like do we need sensors on the roads, and what are the costs and what are the requirements?
So in my opinion, that's the whole beauty of, for 100 years we built roads, the auto folks have built cars, and we've never talked. But we got people like, Gopi, you're in the audience somewhere, aren't you? Yeah, we have people like Ford in the audience, right? And all of a sudden now we have that ability to, instead of spending millions, hundreds of millions of dollars on deploying infrastructure, we can get a small sample of vehicles and characterize our road without any investment. That's huge. That's the game changer. Sir?
You're getting the data in real time?
Yes.
And do you have examples then of how, from the modeling, and as I don't mean to be glib, but it seems pretty intuitive, bad weather, bad roads, you're going to have accidents, right? But you're looking for better deployment of resources and all of that. So do you have an example now of how you've then used the data to do that, and how under, let's say, similar past atmospheric conditions, you would have congestion and accidents, but now because you've used the tool, it's less? Is there a side-by-side that you've done yet on something like that?
So and actually we're gonna have one of our tanker truck with one of the INDOT highway maintenance director out there in the yard this afternoon. So listen to me, but talk to him because he's the guy that looks at these tickers. But when he has the ability to look at a map like this, and you're responsible for several hundred miles, and you can start seeing at a glance what those trends are. This gives you that agile deployment of resources. The other thing is we do after action. After action's after action, but if you can use after action as a learning opportunity and do it better the next time. And a lot of that really comes down to the big win is how aggressive the state has become on the anti-icing pre-treatment. That tend to be a bit more sporadic in terms of which units did it. And when you can start seeing side-by-side comparison on the interstate between adjacent districts, that's been a game changer. So when you give simple graphics to the people that are doing this, it needs to be a picture book approach to traffic engineering and winter operations. That's been the game changer, simple graphics. And these graphics, I'll pull up some real-time demos in just a little bit, but we can do that right now. Another question? Yes.
Just then you mentioned that you use the data from Wagezo as a source of connected. Thank you. Just then you mentioned you use the data from Wagezo as a source of connected vehicle data, and we also know that the GPS data from phone is another source of connected vehicle data, which can also reflect real-time traffic patterns. So, what is the difference between these two kinds of data in terms of data error, communication delay, and other factors? Thank you.
I haven't worked with the phone data in the winter operations space. I will tell you in the work zone, the problem, we don't have enough GPS fidelity to know lane by lane. The nice thing about connected vehicle data is you get sufficient GPS resolution to know which lane, and that becomes a really big deal when you're trying to figure out service roads and so on. I absolutely believe cell phone data is an important data set, but If I can get the high fidelity from the connected vehicle data. And the other win is I really want that enhanced data. It's really a good lead in. This is some work that Justin's been doing with Howell, where we've, another colleague at Purdue, where we're looking at friction data coming in from the vehicle. So when we start talking about some of those enhanced data elements, that's why I really want to be in the car. I want to know ABS, I want to know traction control, I want to know hard braking, hard acceleration. So let's look at, we did this with Near Dynamics, and this is just a little video of a front going across Chicago. The high level, the way Howell's got this slide laid out is kind of, these are the major routes along left-hand side on Chicago. And what you want to be able to do, I want to kind of go back and watch this front move across. So right here we see lots of green. Now I'm going to move the mouse a little bit. Now it comes across, comes across, comes across, comes across. Do you see the friction deteriorating on the road? That's why we want connected vehicle data, because it's not, I think it goes back to, let's start with speed, heading, location, that's good. But we really need, and that's why I'm so excited to see the automotive OEM and the tier 1 folks here, because that's what we got to be doing. We got to be building that partnership, because it's not just the thing that the friction data gives us is it then tells us, okay, not just people are going slow, but it gives us some real better indication on the surface conditions. Sir?
Thanks. And I was wondering about this real-timeness of the data. So you were looking at speeds and position, and I believe you mentioned around 12 or so hours. You could see the picture and see what's happening. Whereas compared to friction, if you look at friction coefficient, do you get a lot more anticipation in that sense?
Okay, so what was the question?
Thank you. Yeah, the question was looking at the anticipation that, let's say, this snowplow or this de-icer truck has, looking at vehicle trajectories versus looking at something like a friction coefficient.
So friction coefficient is probably one more data element. I would say where friction is most exciting to us is for we run into these quote unquote freezing fog conditions.
Right.
And those are those edge cases. You got the weather forecast gives you a 10% chance of this. If we can get those early indications of bridge deck icing, and if we can, a call out takes, pick your number, 2 hours, 3 hours to get people out. Those calls start coming after we have crashes that state police calls in. If we can start seeing, okay, and we've all driven over these situations, ooh, that was a little dicey, and then we go on. But when we have that, if the car is telling us that, that is an incredibly valuable data point.
Right.
So
yeah, it's looking at whether slip has started versus there's already a crash and people are slowing down.
You got it right. So please, everybody, not to be the OEMs in the room, the tier 1. I hope you guys all heard that. This is such important information. As we heard Kristen talk this morning, how do we get to Vision Zero? How do we start saving lives? We kill a lot of people out there on the roads during winter weather. Anything we can start doing to work together to chip away on that is absolutely huge. So great question. We got great audience participation today. Gopi.
On the friction data, are you getting enough samples of data from the ABS for traction control?
It's still sparse. So here's where we're at with that. So this is where we need strong. We're getting enough samples to show it during winter conditions. We are not getting enough samples right now to get to that proactive use case. But I think our job as a university is to paint that vision of where we want to go. And then if we get a company like Ford says, man, we're all in on this, I think you can have a huge impact. So if that wasn't a subtle encouragement, I think there's a bit, and I realize you guys got to make a business case for it, but I think it's I think there's going to be a market out there for this.
Yeah, I think actually, just to make one point on that data, I think we were in a panel discussion on this data sharing, and one challenge that multiple OEMs brought up, we say we have the data, we just don't know how to efficiently share. That's what it has to be. Like, it is, the overhead of sharing is a lot more troublesome than the availability of the data.
We'd love to talk to them, Gopi.
I know, but I think we need to address it as an overall industry. How do we? Because if I'm saying the data is worth $1, but it's $100 worth packaging, then the cost of the data looks like $101. That's not. So I think that's one of the things that have been promoting in terms of the way we need to think about these. Like, hey, I need to be able to trade data like that on an exchange. If I wanted to buy one share in the Ford, previously I used to write a full contract. Now I can go on e-trade. It should be like that. Right? It should be a market. So that's the way we see that. There's a big overhead. I think somewhere we need to resolve that to be able to really unleash a lot of use cases that they come up. Now to have friction data even from our vehicle side.
Absolutely. Any other questions? Sir.
What other pieces of data can you get from your collaboration with Wejo in this case? I know we talk a lot about speed, you talk about friction data right there. What about like lane departure? Was that also an option? Or wipers on, lights on? Is there a lot of, how deep is it?
So we can absolutely get wiper data. Wiper data's been around for a while. It's good, but actually National Weather Service HRRR data is probably better because it gives us more information. Gopi and I, we've published a paper with Justin on looking at lane markings. There is a whole nother topic in that space on two fronts. How good can we see the lines? And that benefits not just autonomous vehicles, that benefits sighted drivers. So there is a huge frontier of opportunity in lane marking quality. If you're interested in that, Gopi's done a paper with Justin. We can give you some of the contact information on that afterwards. So I did promise, okay, when we're getting close, I think my time goes to like 12:15. I did promise a live demo of kind of weather. Everybody says, is this really real time? So you live by these demos and let's hope it goes. Internet's good right here, but let's just look at, I'm gonna just do this. This is I-65. Friday night, and you can see, can you see kind of a trend right here of kind of traffic slowing from a north to south? That was the front coming through. The tornado impacted right here, and just to show you the impact of the tornado, we pulled this off somebody's Twitter page. Those are a bunch of hogs that used to live in that barn, and that barn is scattered there along the interstate. Now, if we look at the dashboard right here, and I'm just going to zoom in here on kind of this mile marker 140 to 160. So this isn't winter weather, but it's winter weather, connected vehicle for winter weather versus connected vehicle data for tornadoes. I mean, when I put the talk in for Sam on this, I didn't know we were going to have a tornado on Friday, but now I'm zooming in. So this is that real-time dashboard coming up. And you can actually see the impact. The tornado hit right there. Saturday, everybody is slowing down to look at the debris there. So if you look right here, the interstate's open, but right there at about 154, both directions, we got queues that pick your number 6 miles long. And then worse, do you see all those hard braking? Who asked about the enhanced data, right? So this is the hard braking. See all the hard braking there, those dots? And they're all at the back of the queue. That's where our most hazardous spot is driver stopped in traffic, distracted, driver coming along, running in behind. And then, if we look, and I know I'm just a little bit over time, but I'll do one more. We can see we actually did a rolling slowdown yesterday to get wires across the road. And now I'll look at the rolling slowdown. This is the rolling slowdown right here. And I got 2 directions. So do you see the rolling slowdown right here? Where that black, right there is where the rolling slowdown starts. And watch as I move the rolling slowdown down. See that little balloon over on the map? Goes through. And then they get past the 153.4 where they're putting the wires across. Life is good. And you can see travel time went up to about 32 minutes from 20 minutes. So I know I've got Sam.
You have until 12:30, so you're good.
Oh, okay. Oh, I thought okay. I couldn't. Okay.
Yeah.
Okay. Quick introduction. Sam is the director of the CCAT Center at Purdue, and the credit goes for him for funding the autonomous brine vehicle. And I see Brian McGavick has slipped in the back. Brian will be out there for the demo. Brian, I don't know if you got here at the beginning, but I made sure I gave a plug for your vehicle. And you might have used your mug shot on that without, maybe I need to get your written consent for that photo. But anybody that goes to my presentation knows they're going to get a photo. Yes?
So I have a question for you. I know it's not focused on this, but I'm wondering about the application of this for cyclists, for pedestrians, for vulnerable road user protection. Can you talk a little bit about the application, the promise and challenge for using connected vehicle data?
Yeah, it's kind of funny. We just had, not funny, I mean, good interesting coincidence as you brought that up. So vulnerable road users are a hot topic, and my first one is I can't resist getting a sound bite in for, I forget who just posted something that work zone workers are vulnerable road users. So I think we talked about that. But the other vulnerable road users is where you have trail crossings across roads. So I absolutely believe, and we're just starting to look at it, is we will see hard braking events at those trail crossings. And I absolutely believe that using connected vehicle data to start prioritizing where are some of those trail crossings that we should look at, because roughly, and it's in work, and I don't know what it is on secondary roads, but on work zones, we have about 150 hard braking events for every crash. So, and this is no secret. The insurance companies figured out hard braking events are a good indicator of crashes. That's why if you put a dongle on your car, they'll give you a discount or coach you on better driving. So, short answer is I absolutely believe hard braking can be used to start triaging where we have some trail crossings going across that we need to put some additional focus on. Doesn't solve all the problems, but I think it's where we start picking off some of those items. Down the road, it would be great when we have some of these ADAS systems that maybe could recognize pedestrian conflicts, right? That could be a future data attribute down the road. It's not there right now, but we can do something with hard braking. Next question. Yes? I think Sam's got a mic for you.
Is there a benchmark that can be found, like if they had different areas and the severity of the weather and what kind of effect it has on the vehicles? Can there be a benchmark made? And if you have the data from different places, do you see a similarity of that, or is there a difference between two places?
So trying to frame the question, so you're trying to look for that business case for an ADAS system?
Can be used for that, but mainly for if there is a particular area where there are not enough connected vehicles, but from the pattern which you see in one area, can that be used? The same pattern can be used in a different place.
Yeah, so here's what we typically do with, and we certainly do this in the traffic signal analytics space, right? If you only have 5% of the vehicles going through there, you don't have enough data in real time to characterize a traffic signal. But if you take, if you take 4 weeks of data, an entire month, and you overlay that data, so the same time every day of the week, now we've got very good penetration, and in fact we do that. We do dashboards where we can then pull up traffic signal analytics, and I don't know if I got any in Michigan or not. You can then just pull up, just to kind of, you pick up a couple. I'll just do. Pick those signals. I'm not doing a very good job. You draw around that, and then you analyze it. And what this is going to look at, this looked at March 4th to April 3rd. Well, okay, I picked some signals. Everything's green. Everything's good there. There's not some red. But that's the sort of thing that you can do with connected vehicle when you have low penetration, average multiple days. Does that tell you how a work zone does? No, but certainly there's some use cases, low penetration, that works well.
Okay. Yeah.
Great.
Sir.
Thank you for the presentation, and kind of lost in those fancy figures. I'm trying to connect the dot between the friction coefficient and also the trajectory. Are those the friction coefficient is inferred from the trajectory data, or is it completely from the obtained from the different data set?
Different data set. So I think, and that's that whole research opportunity. I think, Henry, you kind of touched on that this morning, is this is the wild west of data out there. And I think there's a huge opportunity here in the university, private sector environment to start figuring out what the use cases are. I hope, and I think this is a really good kind of recap question, right? I hope what you took away from the talk was that you can absolutely use connected vehicle data and either at a macro level to see how roads are behaving, or you could come into a very detailed analysis of trajectories and see that. All that tells you is speed. It doesn't tell you root cause. What we really want to know is, okay, what might be influencing it? One of the data elements that we said you can also bring in would be that friction value. So that's what we call an enhanced data element. And I think what we need to be looking at, and I think this is where there's so much opportunity to partner with the auto industry, is we start fusing these data, we can start figuring out, and I think if somebody came up with the question is friction good enough in real time? No, it's not, because we don't have enough samples. But if we can all of a sudden paint that picture for the Fords and the GMs and the Volvos and the Volkswagens to say, we're going to start providing that information. Now we've made a breakthrough, right?
Okay. Thank you.
Another question. So what are some of the considerations for, as you talk about connected vehicles, the assumptions for latency, bandwidth access? Would each car have to have its own subscription service? Would you have a general subscription service? And maybe a little bit about the data that's to be shared, maybe some considerations around that.
Yeah, so latency is really a hot topic, and I don't have the slide in front of me, but if you talk to me afterwards, we're getting like 95% of the data within 3 minutes, and we're getting 50% of the data within less than a minute. So that end-to-end, so what we do is we get the time tag on when it comes in versus the time tag that it says in the record. We take that and we keep track of that. And I can show you a plot on what that latency is. But in my opinion, most of the time we can see an incident in the data before the 911 center can. It's usually, we see it in the data 3 to 4 minutes before it makes its way to dispatch, which I think is good. It's not perfectly real time. It's still not at the level of like real-time detector actuation in a traffic signal, but it's certainly good enough for operational analysis. Gopi.
Darcy, a question and a comment. I think from looking at the data, it looks like actually the behavior of the traffic and other things are quite deterministic and predicted. I don't know, is there anyone making an attempt to develop AI ML models on these things to be able to predict? Just based on the conditions that are developing, you know that it's going to happen now.
You said based on weather?
Based on the weather conditions and the precipitation that might be coming up, not necessarily wait for the conditions to develop, right?
Yeah. So there's a product on the market, MDSS, that gives you treatment, and there's a couple of them out there, gives you treatment recommendations. That's what we use in Indiana. I would argue, and I think this is where we call it the Earth and Atmospheric Science, the weather forecasting folks are really interested in this space. All the models have been developed over the years that focus on how much you see snow accumulating on the grass and the ground. What we really care about is what is impacting friction. And the kind of the edge cases that we worry about are that classic, 10% chance of a trace. A trace can cause just an immense amount of impact that might not even, maybe the weather forecasters kind of think is as nuanced. So I absolutely believe it's going to open up a new frontier on some of that. And that's where, the temperature sensors on the vehicles could help calibrate those models.
Right. I mean, it is you have the much more granular data model than before. So.
And you absolutely have varying climate moving across.
Yeah.
So absolutely. So
Thanks.
love to keep working with you on a project on that, Gopi.
So when that tornado hit and hit the hog barn and the traffic slowed down, were you sure that the traffic was slowing down because of the tornado, or were people actually seeing pigs fly?
So it's kind of interesting. So good comment though on the daylight. Do you see the impact? People didn't start slowing down until they could see it at night. After the tornado went through, you see right there, the tornado was right there. They had debris in the road for a little bit, but then when it was dark, they didn't see the debris. The sun came out, and then they see all the debris out there. They slow down. It gets dark, and then we have the same thing the same day, the next day, because people can see the debris. We see that kind of Gawker's Gap or whatever pretty frequently. That's a good comment, pigs fly. That's a good one.
Thank you.
Other questions? So, last question, and then.
Okay. Yeah, just hold on. Yeah.
What potentials for improvement on this regarding like use of other source of data or fusing other datas with this do you see? Do you find that valuable, or do you think like with less amount of data we could predict this, that would be more valuable?
Oh, I always want more data. I always want, but then you get down to, you want more data for research, but then you kind of knock it down to what's that bare minimum you need to make a decision on. So, I don't know, hopefully that answers your question.
Mm-hmm. And then, have you ever had any issues regarding interstate or cities data sharing and communications? Has there been any friction on that regard?
So nobody's ever against sharing data conceptually. It's a workload thing, right? So that's the beauty of connected vehicle data. What we do in Indiana, we could scale to the whole 50 states. Whereas if you start trying to pull together data sharing and communication and IP protocols and passwords and VPNs, you spend a year in meetings and you haven't got anywhere. And you can buy the data and you can just see anywhere in the country. So last comment, please this afternoon during the quote unquote strolling dinner, stroll out to see these two vehicles that will be out there in the parking lot. Please take a time to meet Justin and Hayden and Brian back there, wave guys. And Sam, thank you for investing in this project. And then more importantly, thank you guys. This is like, and oh, there's, I thought Henry, actually, good. So this has been a really fun session. And so thank you guys for participating.